So x is equal to square root of 1 over the square root of 2. And I wrote it that way simply because I want to go ahead and rationalize. Most likely in the back of your book, you're not going to see that as a solution. So we're going to rationalize by multiplying by square root of 2 over square root of 2, which is going to give me square root of 2 over 2 is my final answer for x. All right, again though, make sure you fully answered the question. We did find x, but notice there was one more part. What is the minimum area? Well, to find area, I need to go back and substitute in that answer I just got. Square root of 2 over 2 squared. All right, that's going to give me square root of 4 over 4, which of course is 2 over 4, or 1/2 units squared. All right, so again, just be sure once you finish that you actually answer the question completely. All right, we're going to take a look at one more example, and this time we're going to look at one that doesn't turn out to be quadratic, so we can't use our cute little formula on it. And in fact, what you're going to have to do is use your graphing calculator to find this solution. So get those handy. Our last example, a cylindrical can open at the top is to hold 500 centimeters cubed of liquid. Find the height and radius that minimize the amount of material needed to manufacture this can. All right, so draw your cylinder and be sure to label it. Radius and height. Okay. All right, then write the equation for what it is you're looking for. And again, I chose this one because we had just discussed one the other day. We're trying to find the height and radius that minimize the amount of material needed to manufacture the can. And again, this is surface area because we're trying to make this can. So you remember the surface area formula, but with one change. The can is open at the top. There is no top, so we need one circle for the bottom, pi r squared. And then we need, if you'll remember this, how to find the rectangle that wraps around the can. If you'll recall, that is going to be the circumference of the circle, 2 pi r, times the height, h. Okay, so there's our equation. Just one slight change. We only have one circle this time instead of 2. Write a second equation from the information given and solve for one of the variables. Well, the other thing I know is that the can hold 500 cubic centimeters of liquid. That's volume. So I need the volume formula for a cylinder, which we, if you recall, we had just the other day. Volume is the area of the base times the height. My base is pi r squared, and my height is h. Make your substitution. Volume is 500 equals pi r squared h. And then we need to go ahead and solve it for one of the variables. I'm going to solve for h since it's not to any power. It'll be easier. H is equal to 500 divided by pi r squared. All right, step 4. Combine those two equations again. So my surface area is equal to pi r squared plus 2 pi r h, but I'm going to use this 500 divided by pi r squared in place of h. Cancel. And we end up with the equation. S is equal to pi r squared plus 1,000 over r. Now, clearly, this is not a quadratic. Yes, we have a second power here, but look over here. We're dividing by r, so it's not in the form ax squared plus bx plus c when you have that r in the denominator. You'll figure out later on in this course what kind of an equation this actually is, but for now, we don't need to know that. We're going to still see if we can't find the minimum. All right, to do that though, we're going to have to call on our technology and use our graphing calculator. So let's go ahead and see if we can't figure that out. All right, let's go ahead and enter the equation that we just came up with. So under y equals, go ahead and enter your equation. It was pi r squared, and since there's no r on this calculator, we're going to use x, plus 1,000 divided by r again, which we're representing with x. Okay, so check your equation, pi x squared plus 1,000 divided by x. Now, the hardest part in these problems when you're using your calculator is setting the appropriate window. And again, common sense is what we're going to use to try to figure that out. If you'll remember and look at your equation, ours is in terms of r, which is the radius of the can. Now think common sense wise. What would be the minimum radius that you could possibly have for a can theoretically? Well, 0. Be a silly looking can, but you could have it down to 0. Could you really have a negative radius? Probably not. So what we need to do is set our window so that our x minimum is really somewhere around 0. Now I do like to see a little bit to the left of 0, so I'm going to leave it at -10. Okay? But again, logically, it can't be negative. X max, I'm not sure. I mean, in all honesty, a can could get, the radius could be as big as you wanted it to be. For now, I'm just going to set that at, let's say 20, just to get a feel for it. If I need to go back and adjust it, I certainly can. Scale we'll leave at 1. Now here's the tricky part, the y min. In this case, our y value is actually S, the surface area. Well, that's going to be a pretty big number. Again, I know that the surface area really can't be negative, so I might leave that at -10. But as far as my y max goes, unless I want to sit down and start plugging in some numbers, I'm going to make that pretty big just so I can get a good look at it. Maybe, I don't know, let's try 250. And if we need to adjust, we can. All right, once we're satisfied with our window, let's graph it and see what we see. Okay, I don't see enough, so I'm going to go back and readjust my window. Let me go back and let me expand my y max, because that's probably where I'm not seeing enough of my graph. Let's go up to maybe, let's really expand it. Let's go to 1,000. All right, and let's try graphing again. But this is the process you're going to have to go through. Play with it a little bit. There we go. All right. This is the part of the graph I'm really interested in, because here's my y-axis, and I know that really anything negative doesn't make sense in terms of this problem, in common sense terms. So it's going to have to be greater than 0. However, you will notice there is some graph over here. So in a minute we'll expand that and take, well, let's go ahead and expand it one more time and take a look at that. I am going to look a little bit farther just to show you there's things over there. But again, to remind you, they make no difference because we're talking about a can. Let's go to -20 and take a look. Okay. You've got this piece of your graph, and it is a correct piece of the graph. However, in common sense terms, we're talking about radius greater than 0, so we're only looking on this side. Now, we need to find this point right here, and there are several ways to do that. Probably the most efficient is if you'll go to Second, Trace, or Calculate. Underneath this menu, they have a function to find the maximum and minimum points. We're looking for a minimum, so we're going to select number 3. All right, it's going to ask us for a left bound, and I don't even see my cursor, so I'm going to watch my numbers down here at the bottom until I see that cursor. There he is. And just keep moving to the right till I see him. All right, for the left bound, you want to be to the left of that minimum, which it is, so I'm going to just hit enter. Then it's going to ask me for a right boundary. I keep moving my cursor until I'm to the right of that minimum. Enter. Guess, not really that important since there's not really any confusion as to which point I'm talking about as the minimum, so you could just hit enter at this point, or you can slide it back down a little closer to where you think that minimum is, but it will get there either way. Enter. So now I can see that the minimum point occurs when x, or in my case r, is when my radius is at 5.42 approximately. This over here, remember, is my surface area. So my surface area is 276.79 centimeters squared. All right, find the maximum. So my minimum point, let's write that down. So my minimum point occurred at approximately 5.42, comma, 276.79. Okay, and what were those two values again? This is my R value, so radius is 5.42 centimeters to minimize the amount of material for that can. And the total amount of material necessary is 276.79 centimeters squared. Let's go back and make sure we've answered the question completely. Find the height and radius that minimize the amount of material needed. Okay, I'm missing a piece of that. I have the radius. I need the height. All right, height is equal to 500 divided by pi r squared. Okay, so we're going to plug in. Height is equal to 500, and of course this is going to be an estimate since we're rounding. If you'll keep it in your calculator though, instead of plugging in the rounded value like I'm going to do, you'll end up with a more accurate answer. And once you work that out, we find the height to be approximately 29.37 centimeters. All right, one last piece of advice when doing these problems, just be sure that once you've got the equation written and you've found either the vertex or you've used the technology to find the minimum or maximum point, that you do go back and read that question one more time and just make sure that you've totally answered it, that you are not just answering part of it. Good luck with these problems, and I'll see you again soon.